All right, this is the second part of combining like terms because there's another level of this that we should be able to understand as well. So I made a second part for this. And this part focuses on combining like terms, but using distribution, okay? It brings in a property that we're familiar with, but now it also applies to this skill. So I set it aside for a second follow-up video here. Now I want to remind you, first of all, the distributive property. What does this mean? Well, to distribute means to give something to each member of a group. All right, we use that term in our life. We also use it in math. The algebra example here would be, for instance, when you have a number outside, that value times the two values inside, well, you multiply A by B, and you multiply A also with C. So sometimes when we see this, we summarize it, A times B plus A times C. We're giving the A, we're distributing the A with both of the values inside. Now, sometimes this is nice and simple, and again, here's that same expression, but if it's just numbers, we could do it two simple ways. One is just to think, I can add these two values, 3 and 4. I know that's 7, and I know that really this is 2 times 7, which is 14. But just to kind of show you that distribution still works, even when you have number values, this would be the same as 2 times 3, that right there, plus 2 times 4, that right there. Now, I know 2 and 3 is 6. I know 2 and 4 is 8. Again, we're multiplying those. And now I add them because 6 and 8 is 14. So I get the same value. But this example right here, it almost makes more sense to do it this way, which I totally agree. But sometimes, though, you don't have just 3 numerical values here. You might have an exponent. I'm sorry, you might have a variable. So like, you might have something like this, where you don't know x's value, but you still got to distribute. Well, you still do 5 times x plus 5 times 2. That's where this came from. And we would just say this is 5x and this is 10. So essentially, this distributes to 5x plus 10. Now, sometimes you have a value like this, where maybe this term out here is 5x. And then you have here 3x plus 6. Well, if I distribute this, 5x times 3x, that would be multiplied. But then I also multiply the 5x with the 6. Okay, and I can work from there as well. Or sometimes if you get into more advanced math, 7th and 8th grade, 9th grade, and high school stuff, you might have to do something like this, where you distribute this with each term inside, one at a time. 5 times this, 5 times that, 5 times this third term, and you get a little more advanced math, but it's still the same thinking, because again, the goal is to distribute and to give the outside value to each of the inside ones. At the 6th grade level, we're really just getting right here, okay? We don't get to this quite yet until you get to 7th, 8th grade stuff maybe. Now, these examples right here might just serve as some reminders, but let's look at a problem where you have to distribute and combine like terms, because that is also an expectation of 6th grade math. So if I look right here, before I can do any combining, I need to distribute first. And I see this right here, and this is a clue that I should distribute this part of the problem first. I'm just going to put a little box around it. That needs to be distributed before I can really move on, because I want to multiply the 4 by each of the terms inside. So if I do that, I do 4 times 3x, and I want to add it with 4 times 2. But I still want to take away 7x, so I'm still going to write that. Now, I can multiply here. Like I know I get 12, and there's just an x attached, so I get 12x plus 8 minus 7x. That still hasn't changed. So I've distributed this right here to really get this part. I'll highlight it to show you. This is what happened when I distributed. And then when I carry that through, I really get it to this right here. So in a sense, I really just made an equivalent expression, okay? This right here really turned into that, all right? 12x plus 8. So I want to distribute first. And then after I distribute, now I can really focus on combining like terms. So I have 12x and I have take away or minus 7x. So again, look at your coefficients, 12 and 7, and we know we're doing some subtraction there. That really ends up being, any guesses? 5x plus 8. 5x plus 8. Because if I think about like terms, I'll just highlight these right here. I can combine these, okay, and it was subtraction. And this I could not combine. That 8 had to stay separate because there's no other constants. It's just the 8 all by itself. So this is where I end up. Now, I've combined like terms, but sometimes you got to distribute first. What I want to do now is I want to show you the second one, and I want you to try this one. Because again, you got to distribute first. Because when I look right here, I see that there's some distribution that needs to happen right there. So go ahead, pause it, distribute first, and then take your problem further and combine the terms. All right, let's see how you did. Well, if you distribute first, you would really keep the 2 plus all by itself, but 5 times f, you want to multiply those, and then you want to add it with 5 times 3. So now we can take this a little further. That would be 2 plus 5f plus 15. And once you get to there, think about what can be combined. Okay, we've now distributed successfully. Now we want to combine terms, and I have a constant here, and I have a constant there, and the whole problem is addition, so I want to combine those by adding 2 and 15. So I get 17 plus 5x. Okay, that is where I end up. Now, some people might say, well, I put the 5f first plus 17. Is that okay? And the answer is yeah, because again, when you're adding two things together, the order doesn't really matter. Remember, that's the commutative property. Changing the order is okay. It's legal in math. You can do that. So there's combining like terms, but then there's also the second level of that, which is what happens when you need to distribute first. So you need to also be comfortable with that.